November 11th, 1918. The Meuse-Argonne Forest, France, 10:58 a.m. Private James Dalton, of the American 77th Infantry Division, crouches in a muddy trench. His Springfield model 1903 rifle clutched against his chest. The weapon weighs 9 pounds, its wooden stock slick with rain and grime. For 4 years, men have fought and died across these fields with rifles almost identical to this one. Bolt-action mechanisms that require a soldier to manually cycle each round. 5 shots loaded through the top of the magazine, 1 round already chambered. 6 shots total before he must reload. Dalton has trained to fire 15 aimed shots per minute under ideal conditions. Though in combat, exhausted and terrified, most soldiers manage half that. His hands are numb from cold. His fingers struggle with the metal bolt. In 2 minutes, the armistice will take effect, and the guns will fall silent. But right now, German soldiers 400 yards away are still firing. Dalton works his bolt, ejecting a spent brass casing. He presses another stripper clip of 5 rounds down into the magazine, the metallic click audible even over the distant artillery. 1 round at a time, pull bolt back, push bolt forward, aim, fire, repeat. This is how men fight in 1918. This is how they have always fought. This is the fastest an individual soldier can deliver rifle fire.
26 years later, June 6, 1944, Omaha Beach, Normandy, 7:15 a.m. Staff Sergeant Robert Capa of the 16th Infantry Regiment charges up the beach, his M1 Garand rifle held at the ready. The weapon weighs slightly less than Dalton's Springfield, but everything else has changed. The Garand is semi-automatic. Each pull of the trigger fires a round and automatically loads the next. No bolt to work, no manual cycling. 8 rounds in an internal magazine that feeds smoothly, mechanically, relentlessly. Capa can fire all 8 rounds in less than 10 seconds. 40 aimed shots per minute sustained. 80 shots per minute if he abandons accuracy and simply pulls the trigger as fast as possible. When the 8th round fires, the empty clip ejects with a distinctive metallic ping, and Capa slams in a fresh clip in under 2 seconds. He is back in action before a WW1 soldier would have finished reloading his 2nd stripper clip. Around him, thousands of American soldiers advance with identical rifles, their combined firepower greater than entire battalions carried in 1918. German defenders, many still armed with bolt-action Kar 98K rifles, inherited from the previous war, are overwhelmed by the sheer volume of fire. The beach is chaos, but the Americans are not fighting with their grandfathers' weapons. They are fighting with the future, and the future fires 40 rounds per minute. The transformation of the infantryman's rifle between World War I and World War II represents one of the most significant tactical evolutions in military history. The change was not merely technical, it was philosophical. It redefined what a single soldier could accomplish, how infantry tactics functioned, and ultimately how battles were won or lost. To understand this revolution, we must first understand the world of 1914, when the bolt-action rifle reigned supreme, and when military theorists believed they had perfected the infantryman's primary weapon. When the Great War erupted in August 1914, every major army equipped its infantry with bolt-action magazine-fed rifles. These weapons represented the culmination of 50 years of firearms development, evolved from single-shot breech loaders to repeating rifles capable of holding multiple rounds. The British carried the Lee-Enfield, a rifle with a 10-round detachable magazine and a smooth, fast bolt action. German soldiers carried the Gewehr 98, known for its exceptional accuracy and rugged reliability. French troops used the Lebel and later the Berthier. American forces, arriving late to the war, carried the Springfield 1903,
a design heavily influenced by the German Mauser. These rifles shared common characteristics. All were bolt action, requiring the soldier to manually work a bolt handle to eject the spent cartridge and chamber a new round. All fired full-power rifle cartridges at ranges exceeding 1,000 yards. All were accurate, reliable, and deadly in trained hands. The bolt-action mechanism was elegant in its simplicity. The soldier grasped a handle protruding from the right side of the receiver, lifted it to unlock the bolt, pulled it rearward to extract and eject the spent cartridge, pushed it forward to strip a new round from the magazine and chamber it, then pushed the handle down to lock the bolt. The entire cycle required 4 distinct motions and took approximately 2 seconds for a trained soldier. With 5-round magazine standard on most rifles, a soldier could fire 5 aimed shots in roughly 10 seconds, then needed another 3 to 5 seconds to reload using a stripper clip. The mathematics of this were understood by every infantryman. 15 rounds per minute was the standard for a competent soldier. 20 rounds per minute was possible for exceptional marksmen. Anything beyond that sacrificed accuracy for speed and was generally discouraged.
The rifles themselves were marvels of precision manufacturing. The German Gewehr 98 featured a controlled round feed that ensured each cartridge was guided smoothly into the chamber, preventing jams. The action was so strong it could handle pressures that would destroy lesser weapons. German soldiers trusted their rifles absolutely, knowing they would function in mud, snow, rain, or desert sand. The British Lee-Enfield took a different approach, prioritizing speed over strength. Its bolt had a short throw, requiring less movement to cycle, and its rear locking lugs meant the bolt handle was positioned perfectly for rapid manipulation. A skilled British soldier could fire the mad minute, 30 aimed shots in 60 seconds, though this was considered an exceptional feat rather than a combat standard. The American Springfield 1903 combined elements of both philosophies. Based on the Mauser action, it featured the same controlled round feed and cock-on-opening design that made German rifles so reliable. Its accuracy was legendary. American snipers using modified Springfields regularly made kills at ranges exceeding 800 yards. The rifle's main limitation was its 5-round magazine, smaller than the Lee-Enfield's 10 rounds, requiring more frequent reloading. Still, it was considered one of the finest military rifles ever produced, and soldiers who carried it into combat trusted it with their lives. Loading these rifles required stripper clips, thin metal frames that held 5 rounds in a row. The soldier would open the bolt, position the stripper clip above the magazine, and press the rounds down with his thumb. The cartridges would strip off the clip and fall into the magazine. The clip was then discarded and the bolt closed, chambering the first round. Under ideal conditions, at a shooting range, with prepared ammunition and no stress, this process took 3 seconds. In combat, with cold hands, exhausted muscles, and enemy fire incoming, it often took much longer. Soldiers fumbled with clips, dropped them in mud, struggled to align them properly with the magazine. Reloading was a vulnerability, a moment when the soldier could not fire, could not defend himself.
The cartridges these rifles fired were powerful. The British .303 British round propelled a 174-grain bullet at 2,440 feet per second, delivering tremendous energy at long range. The German 7.92 by 57 mm Mauser was similar, with slightly better ballistic performance. The American .30-06 Springfield was more powerful still, pushing a 150-grain bullet at over 2,800 feet per second. These were not intermediate cartridges designed for short-range combat. They were full-power rifle rounds intended to kill at half a mile or more. The recoil was substantial, requiring soldiers to reacquire their sight picture after each shot. The muzzle blast was ferocious. Firing without hearing protection, as all soldiers did, caused permanent hearing damage. Many WW1 veterans were partially deaf from years of rifle fire. The effective range of these rifles far exceeded the distances at which they were typically employed. A trained marksman could hit a man-sized target at 600 yards with iron sights. With telescopic sights, ranges of 1,000 yards were achievable. Yet, in the trenches of the Western Front, most combat occurred at ranges under 300 yards. The long-range capability of the rifles was largely wasted. What mattered in trench warfare was volume of fire at close range. And here, the bolt-action rifle's limitations became apparent. A soldier armed with a bolt-action rifle could deliver sustained fire at about 10 to 12 rounds per minute in combat conditions. This was sufficient for defensive positions where soldiers could carefully aim each shot, but inadequate for assault where suppressive fire was needed. The psychological experience of firing a bolt-action rifle in combat was intense. Each shot required deliberate action. Pull the trigger, experience the recoil, work the bolt, reacquire the target, aim, fire again. There was a rhythm to it, a mechanical cadence that became second nature to veterans. But there was also a vulnerability. While working the bolt, the soldier was not firing. His eyes were focused on the rifle, not the battlefield. In those brief moments, an enemy could advance, could fire, could throw a grenade. The bolt-action rifle demanded attention, required a soldier to think about the mechanism rather than focus entirely on fighting. Training emphasized marksmanship above all else. British soldiers spent weeks on rifle ranges, learning to hit targets at various distances. German soldiers received similar instruction, with particular emphasis on aimed fire at long range. The prevailing military doctrine held that well-trained riflemen firing accurately could stop any assault. The Boer War had seemed to confirm this, with small groups of Boer marksmen armed with Mauser rifles, inflicting terrible casualties on British forces. Military theorists concluded that modern rifles had made frontal assault obsolete. They were partially correct, but they had not anticipated how machine guns and artillery would come to dominate the battlefield. When war came, the theoretical advantages of the bolt-action rifle confronted the brutal reality of industrial combat. The Western Front devolved into a stalemate, with millions of men facing each other across no man's land. The rifle, designed for mobile warfare where marksmanship mattered, found itself in a static environment where volume of fire trumped accuracy. Soldiers fired thousands of rounds at targets they could barely see, hoping to hit someone in the opposing trench. The careful aimed fire emphasized in training gave way to suppressive fire, shooting to keep enemy heads down rather than to kill. The bolt-action mechanism was adequate for this, but barely. The rate of fire limitation became glaringly obvious during assaults. When soldiers went over the top and charged across no man's land, they needed to suppress enemy defenses with overwhelming fire. But a line of soldiers with bolt-action rifles could only generate so much firepower. Each man firing 15 rounds per minute meant that a 100-man company could deliver 1,500 rounds per minute. This sounds impressive until compared to a single machine gun, which could fire 500 rounds per minute from one position. The infantry rifle had been eclipsed by the machine gun as the primary infantry weapon, yet soldiers still carried rifles because there was no alternative.
Attempts to increase rifle firepower led to various improvisations. Some soldiers practiced rapid-fire techniques, sacrificing accuracy to achieve higher rates of fire. The British Army trained select soldiers to fire the Mad Minute, demonstrating that exceptional marksmen could briefly achieve 30 rounds per minute. But this was exhausting and consumed ammunition at unsustainable rates. Ammunition supply was a constant problem. Each soldier typically carried between 100 and 200 rounds, enough for perhaps 10 minutes of sustained rapid fire.
Resupply in combat was difficult and dangerous. Soldiers learned to conserve ammunition, firing only when they had clear targets. The reloading process created tactical vulnerabilities that experienced soldiers learned to exploit. When an enemy soldier was reloading, he could not fire back. Observant soldiers watched for the moment when an opponent's bolt was open and used that instant to advance or change position. In the chaos of combat, these brief windows of opportunity could mean the difference between life and death. Some soldiers developed tactics of alternating fire with their comrades, one man shooting while another reloaded, attempting to maintain continuous fire. But coordinating this in the noise and confusion of battle was nearly impossible. Close-quarters combat revealed another limitation of bolt-action rifles. In trench raids and hand-to-hand fighting, the long rifle was cumbersome. Its length, typically over 40 inches, made it difficult to maneuver in confined spaces. Working the bolt required space and time that soldiers in desperate close combat did not have. Many soldiers resorted to using their rifles as clubs, swinging them like baseball bats, or stabbing with fixed bayonets. The rifle as a firearm became secondary to the rifle as a melee weapon. This was not what designers had envisioned. Trench warfare had created combat conditions for which the bolt-action rifle was poorly suited. By 1918, military planners recognized these limitations but had few solutions. Some armies experimented with automatic rifles, weapons that could fire continuously while the trigger was held. The French Chauchat and the American Browning automatic rifle represented steps toward increased firepower. But these were squad weapons, heavy, and difficult for individual soldiers to carry and use effectively. They were not replacements for the standard infantry rifle, but supplements to it. The bolt-action rifle remained standard issue because nothing better existed that could be manufactured in sufficient quantities and issued to millions of soldiers. The end of World War I brought an abrupt halt to military innovation. Governments, exhausted by 4 years of total war, slashed defense budgets. Armies demobilized, shrinking to fractions of their wartime strength. The vast stockpiles of bolt-action rifles produced during the war went into storage, enough weapons to equip armies for decades. There seemed little incentive to develop new infantry rifles when millions of perfectly functional bolt-action rifles sat in arsenals. The lessons of the war, including the inadequacies of the bolt-action design for modern combat, were studied but not immediately acted upon. Yet, in design bureaus and experimental workshops, engineers understood that the future lay in self-loading rifles. The concept was not new. Semi-automatic rifles, which used the energy of firing to automatically load the next round, had been attempted since the late 1800s. But early designs were unreliable, too heavy, too complex, or too expensive for military adoption. The challenges were substantial. A semi-automatic action required precisely machined parts, tight tolerances, and robust materials. It needed to function reliably with varying ammunition, in extreme temperatures, and under the abuse of military service. Most experimental designs failed one or more of these requirements.
The breakthrough came from understanding gas operation. When a rifle fires, the burning propellant creates enormous pressure that propels the bullet down the barrel. Some of this gas can be tapped off through a port in the barrel and used to drive a piston or operating rod that cycles the action. This gas operation concept had been used in machine guns, and several designers realized it could be adapted to rifles.
The key was creating a system light enough for an individual soldier to carry, but robust enough to function reliably. American designer John Garand spent years perfecting such a system, and his M1 rifle, adopted by the U.S. Army in 1936, would prove to be the most successful semi-automatic rifle of World War II. The M1 Garand represented a quantum leap in infantry firepower. Weighing 9.5 pounds, only slightly heavier than the Springfield it replaced, it fired the same .3006 ammunition, but did so semi-automatically. The soldier pulled the trigger, and the rifle fired, ejected the spent case, loaded a fresh round, and cocked the hammer, all in a fraction of a second. The soldier simply had to pull the trigger again to fire the next round. No bolt to work, no manual cycling. The rate of fire jumped from 15 rounds per minute to 40 or more, limited only by how fast the soldier could aim and pull the trigger. The 8-round capacity, loaded via an en-bloc clip that fed from the top, provided sustained firepower without frequent reloading. The Garand's gas operation system was elegant. A small port near the muzzle tapped gas from the fired cartridge. This gas drove an operating rod rearward, which unlocked the bolt, extracted and ejected the spent case, cocked the hammer, and compressed a return spring. The spring then drove the operating rod forward, stripping a fresh round from the clip and chambering it. The entire cycle took milliseconds. The soldier felt only a slight impulse, far less than the recoil of firing. The rifle was ready to fire again instantly. This automatic cycling removed the human element from the loading process, eliminating fumbling with bolts and allowing the soldier to maintain focus on aiming and firing.
Loading the Garand differed from bolt-action rifles. Instead of stripper clips that left the clip behind, the Garand used en-bloc clips that entered the rifle with the cartridges. The 8-round clip was inserted into the magazine from the top with the bolt locked back. When pushed fully in, the bolt released and chambered the first round. After the 8th round was fired, the empty clip ejected automatically with a distinctive metallic ping, and the bolt locked open, signaling the rifle was empty. A fresh clip could be inserted immediately. With practice, soldiers could reload in under 2 seconds. The system was fast, intuitive, and reliable. The Germans, observing American rifle development, pursued their own semi-automatic designs, but production difficulties and the enormous stockpiles of Kar-98K Mauser rifles prevented widespread adoption. The Gewehr 41 and later Gewehr 43 were produced in limited numbers and issued primarily to designated marksmen. Most German infantry throughout World War II carried the same bolt-action Kar-98K their fathers had carried in World War I. The rifle was reliable and accurate, but it was fundamentally an 1898 design fighting a 1944 war. German soldiers facing Americans armed with Garands quickly learned they were outgunned. The Soviet Union developed the SVT-40, a semi-automatic rifle that showed promise but suffered from manufacturing quality issues and harsh service conditions on the Eastern Front. Soviet industry prioritized submachine gun production over semi-automatic rifles, and most Soviet infantry continued to use Mosin-Nagant bolt-action rifles throughout the war. The British experimented with semi-automatic designs, but never adopted one for general issue, their infantry carrying Lee-Enfield bolt-action rifles from 1939 to 1945. The Americans were unique in equipping their entire infantry force with semi-automatic rifles, giving every rifleman firepower that other armies could only dream of.
The tactical implications of this firepower advantage were enormous. An American infantry squad with 8 Garand-armed riflemen could deliver over 300 rounds per minute of sustained fire. A German squad with bolt-action rifles could manage perhaps 120 rounds per minute. In firefights, the Americans could put 3 times as many bullets down range. suppressing enemy positions more effectively and giving their own forces freedom to maneuver. The volume of fire was so overwhelming that German soldiers often believed they were facing automatic weapons, when in reality, they were simply hearing semi-automatic rifles fired rapidly. General George Patton, never one for understatement, called the M1 Garand the greatest battle implement ever devised. While hyperbolic, his assessment reflected the reality that American infantry possessed a significant advantage over their opponents. In the hedgerows of Normandy, in the forests of the Ardennes, across the Rhine and into Germany, American soldiers with Garands outshot German soldiers with K-98s. The Germans had superior machine guns, better tanks early in the war, excellent artillery. But at the level of individual infantry combat, the American rifleman with his semi-automatic Garand held the edge. The experience of firing a Garand in combat was fundamentally different from firing a bolt-action rifle. The soldier aimed, fired, and the rifle was immediately ready to fire again. There was no interruption in focus, no attention diverted to working a bolt. The soldier could maintain situational awareness, could track targets, could respond to threats without the mechanical distraction of manual cycling. This psychological advantage was as important as the practical increase in rate of fire. Soldiers felt more confident, more capable, less vulnerable. They could lay down suppressive fire that kept enemy heads down, could engage multiple targets in rapid succession, could break up enemy attacks with sheer volume of fire.
The distinctive ping of the ejecting clip became legendary. As the 8th round fired and the empty clip flew out with its metallic ring, soldiers knew their rifle was empty and needed reloading. This sound was audible to nearby enemies, theoretically alerting them that the American soldier was vulnerable. Some soldiers worried that enemy troops listened for the ping and rushed forward during the reload. In reality, combat was too chaotic and noisy for this to be a practical concern. The reload took only 2 seconds, hardly enough time for an enemy to exploit the opportunity. The ping became instead a psychological weapon, a signal to the enemy that tremendous firepower had just been unleashed and more was coming. Training for the Garand emphasized marksmanship and mechanical familiarity. Soldiers learned to field strip the rifle, cleaning and maintaining it in all conditions. They learned that the Garand, while reliable, required proper lubrication and care. They practiced loading and reloading until it became instinctive. They fired thousands of practice rounds, learning the rifle's characteristics, its point of impact at various ranges, its behavior in different conditions. By the time American soldiers reached combat, they were intimately familiar with their weapons and confident in their ability to use them effectively. The Garand was not without limitations. The 8-round capacity, while superior to 5-round bolt-action magazines, was still limited. The in-block clip system meant the rifle could not be topped off. If a soldier fired 3 rounds and wanted a full magazine, he had to eject the partially loaded clip, wasting 5 rounds, and insert a fresh 8-round clip. In practice, soldiers learned to manage their ammunition carefully, firing the rifle dry before reloading. The rifle was also slightly heavier than bolt-action rifles and more complex, with more parts that could potentially break or malfunction. In extremely dirty conditions, the gas system could become fouled, reducing reliability. Ammunition consumption became a logistics challenge. Where a WW1 soldier might fire 50 rounds in a day of combat, a WW2 soldier with a Garand might fire 200. Supplying this ammunition required expanded logistics, more trucks and trains carrying more supplies. American industrial capacity made this possible, but it represented a fundamental shift in how armies thought about infantry operations. Firepower was no longer limited by individual soldier capability, but by the supply chain's ability to deliver ammunition. This was total war waged with industrial logistics, and the Americans excelled at it. The German response to American firepower advantages was telling. Unable to equip their infantry with semi-automatic rifles in meaningful numbers, they instead developed the Sturmgewehr 44,
the world's first assault rifle. This revolutionary weapon fired an intermediate cartridge, less powerful than a full-size rifle round, but more powerful than a pistol round, and was capable of selective fire, either semi-automatic or fully automatic. The STG-44 represented a different philosophy, prioritizing controllable automatic fire at short ranges over long-range accuracy. It was an admission that modern infantry combat occurred at close range, where volume of fire mattered more than precision. Only about 425,000 STG-44s were produced before war's end, too few to affect the outcome, but the design pointed toward the future of infantry weapons. The contrast between WW1 and WW2 infantry tactics reflected the evolution of rifles. In WW1, infantry assaults were conducted in waves, men advancing in lines across no man's land while machine guns provided covering fire. Individual riflemen contributed to the assault primarily through their presence and morale rather than their firepower. Casualties were horrific because soldiers could not generate sufficient suppressive fire with bolt-action rifles to keep enemy machine gunners from decimating the attacking waves. The stalemate of trench warfare persisted partly because infantry lacked the firepower to overcome prepared defenses.
In WW2, American infantry tactics emphasized fire and movement. Small units advanced by bounding overwatch, some soldiers laying down suppressive fire while others moved forward. The Garand made this practical. Soldiers providing covering fire could maintain continuous streams of bullets, keeping enemy heads down while their comrades advanced. Once in new positions, the roles reversed. This leapfrogging movement allowed infantry to close with enemy positions while minimizing casualties. German soldiers, often unable to return equivalent fire with their bolt-action rifles, found themselves pinned down and outmaneuvered. The psychological impact on enemy forces facing Garands was significant. German after-action reports noted the intensity of American rifle fire, describing it as overwhelming and demoralizing. Soldiers who had fought on the Eastern Front, where Soviet infantry primarily carried bolt-action Mosin Nagants, were shocked by the volume of fire American infantry could generate. Some German units reported believing they faced automatic weapons when encountering Garand-equipped infantry. The reality that every American rifleman could fire as rapidly as a German light machine gunner was difficult for German tactical doctrine to counter. Individual marksmanship so emphasized in World War I training remained important but evolved. The ability to hit a target at 600 yards with iron sights mattered less than the ability to put rounds on target rapidly at 200 yards. Combat ranges had decreased as tactics evolved and rifles adapted accordingly. The Garand was accurate to long ranges, certainly capable of hitting targets beyond 500 yards. But most combat engagements occurred much closer. The semi-automatic action allowed soldiers to fire multiple shots at moving targets, increasing hit probability. If the first shot missed, the second and third followed immediately, bracketing the target.
The legend of the Mad Minute, the British feat of firing 30 rounds per minute with a bolt-action rifle, was rendered obsolete by semi-automatic rifles. An average American soldier with a Garand could casually exceed 40 rounds per minute without exceptional training or effort. The gap between exceptional bolt-action performance and routine semi-automatic performance had closed and reversed. Technology had democratized firepower, making every soldier as effective as elite marksmen had been in the previous war. Maintenance requirements differed significantly. Bolt-action rifles were mechanically simple, with few moving parts. A soldier could field strip a bolt-action rifle in 30 seconds, using no tools, clean it with basic materials, and reassemble it quickly. The Garand was more complex, with a gas system, operating rod, and multiple springs and pins. Field stripping required more knowledge and care. The gas system needed periodic cleaning to prevent carbon buildup from fouling the action. Soldiers received extensive training in Garand maintenance, learning to diagnose and correct common problems. In well-maintained units, reliability was excellent. In poorly trained or supplied units, the complexity could become a liability. Environmental conditions affected the rifles differently. Bolt-action rifles functioned in extreme cold, mud, sand, and rain with minimal issues. The manual operation meant the soldier could force the action to cycle even if fouled. Semi-automatic rifles were more sensitive to environmental factors. Mud in the action could cause failures to feed or eject. Extreme cold could thicken lubricants, slowing or stopping the automatic cycling. Sand and dust could cause similar problems. American soldiers learned to protect their Garands, using rifle covers, cleaning frequently, and applying appropriate lubricants. In North Africa, specialized cleaning procedures were developed for desert conditions. In the Pacific, humidity and jungle moisture required constant attention to prevent rust.
The Pacific theater presented unique challenges for the Garand. Jungle warfare occurred at very close ranges, often under 25 yards, where the rifle's long-range accuracy was irrelevant, but its rapid fire was critical. Japanese infantry tactics emphasized sudden, close-range assaults, banzai charges, where soldiers rushed American positions in waves. The Garand's ability to deliver rapid fire at close range made it devastatingly effective against these attacks. American soldiers could fire 8 rounds in seconds, reload in 2 seconds, and fire 8 more, creating a wall of bullets that stopped Japanese assaults cold. Japanese soldiers, many armed with bolt-action Arisaka rifles, could not generate equivalent firepower. The famous ping of the ejecting clip became part of the soundtrack of WW2 combat. Soldiers described firefights as a cacophony of rifle fire, punctuated by the metallic ring of clips ejecting and the snap of fresh clips being inserted. The sound was distinctive and became associated with American infantry. In post-war interviews, German veterans often mentioned the sound of American rifles, describing the continuous crack of semi-automatic fire as intimidating and demoralizing. The psychological warfare value of sheer noise and fury should not be underestimated. Soldiers under fire often overestimated the number of enemies they faced based on the volume of incoming fire. Ammunition types evolved to take advantage of the Garand's capabilities. While ball ammunition remained standard for general use, armor-piercing rounds were issued for engaging light vehicles and fortified positions. Tracer rounds, which burned brightly to show the bullet's path, were interspersed to help soldiers observe their fire and adjust aim. The standard load was 1 tracer for every 5 ball rounds, though this varied by unit and situation. The ability to fire tracers rapidly helped soldiers walk their fire onto targets, especially at longer ranges, where Kentucky windage, adjusting aim based on where bullets struck, was necessary.
The cost differential between bolt-action and semi-automatic rifles was substantial. A Springfield Model 1903 cost approximately $25 to manufacture in 1918. An M1 Garand cost about $85 in 1943, over 3 times as much. The complexity of manufacture required skilled labor and precision machinery. Yet, American industrial capacity made mass production possible. By war's end, over 4 million Garands had been produced, enough to equip the entire Army and Marine Corps. The investment in superior weapons paid dividends in combat effectiveness and reduced casualties. Soldiers equipped with Garands accomplished missions that would have cost far more lives if armed with bolt-action rifles. Training time increased with the semi-automatic rifle. A recruit could be taught basic proficiency with a bolt-action rifle in a few days. The Garand required more extensive instruction, typically 2 weeks of dedicated training covering operation, maintenance, marksmanship, and tactical employment. This investment in training created more capable soldiers who understood their weapons intimately. The complexity of the Garand meant that soldiers needed to think less about the mechanics of firing and more about tactics and target selection. The rifle became an extension of the soldier rather than a tool requiring constant attention. The evolutionary path from bolt action to semi-automatic rifles marked a transition in military philosophy. WW1 doctrine emphasized individual marksmanship and viewed the rifle as a precision instrument for engaging targets at long range. WW2 doctrine recognized that combat was chaotic, occurred at shorter ranges, and required volume of fire over precision. The semi-automatic rifle embodied this shift, trading some long-range accuracy for dramatically increased firepower at combat ranges. This was not a degradation, but an adaptation to the realities of modern warfare.
By 1945, the superiority of semi-automatic rifles was undeniable. American infantry had proven in every theater that rapid firepower dominated bolt-action designs. Yet many armies would continue using bolt-action rifles for years after the war. Britain kept the Lee-Enfield in service until the 1950s. The Soviet Union only gradually transitioned to semi-automatic and then automatic rifles. Economic factors played a role. Enormous stockpiles of serviceable bolt-action rifles existed, but so did institutional inertia and resistance to change. The American adoption of the Garand in 1936, before war began, reflected forward-thinking leadership willing to invest in superior weapons despite higher costs. The human cost of this technological gap was measured in lives. German soldiers facing American infantry with Garands suffered higher casualties than their WW1 counterparts had inflicted on bolt-action equipped enemies. The ability to put more bullets downrange meant more hits, more suppression, more successful assaults. American casualties, while still significant, were lower than they would have been if armed with bolt-action rifles. The investment in superior weapons saved American lives, a calculation that military planners understood and that justified the expense and complexity of semi-automatic rifles. The lasting legacy of the Garand extended beyond WW2. It served through the Korean War, where its reliability and power were again proven superior to the intermediate cartridge rifles emerging elsewhere. It influenced post-war rifle design, with nearly every modern military rifle using gas operations semi-automatic or automatic actions derived from principles proven in the Garand. The M14 rifle that eventually replaced the Garand was essentially an improved Garand with a detachable magazine and selective fire capability. The echoes of John Garand's design persist in rifles still in service today. The contrast between the soldier of 1918 and the soldier of 1944 extended beyond their rifles but was embodied by them. The WW1 soldier with his bolt-action rifle was a product of 19th century military thinking, an individual marksman expected to carefully aim and fire at visible targets. The WW2 soldier, with his semi-automatic rifle, was a modern infantryman, part of an integrated combat system where individual firepower combined with artillery, armor, and air support to create overwhelming combat power. The rifle had evolved from a tool of individual combat to a component of combined arms warfare.
General Patton's assessment that the M1 Garand was the greatest battle implement ever devised reflected not just the rifle's technical excellence, but its role in transforming infantry combat. For the first time in history, every infantryman possessed firepower that approached crew-served weapons. The democratization of firepower that the Garand represented changed warfare fundamentally. No longer were machine guns the only source of sustained fire. Every rifleman was a threat capable of dominating his immediate area with rapid, accurate fire. The statistical reality was stark. In WW1, a soldier with a bolt-action rifle fired approximately 15 aimed rounds per minute. In WW2, a soldier with a semi-automatic rifle fired 40 or more. This near tripling of individual firepower multiplied across entire infantry divisions created combat power that WW1 commanders could only have imagined.
An American infantry division in 1944, with its Garands, could generate more rifle fire than 3 WW1 divisions combined. This concentration of firepower enabled the rapid, mobile warfare that characterized WW2 operations, where infantry could assault and overcome prepared positions without the months-long stalemates that plagued WW1. The men who carried these rifles understood their advantage. American soldiers who survived the war often spoke of their confidence in the Garand, their trust that it would fire when needed, their appreciation for the firepower it provided. German prisoners interrogated about American weapons consistently mentioned the semi-automatic rifles, describing them as superior to their own arms and expressing frustration at facing an enemy so well equipped. The technological gap was not insurmountable. German soldiers were skilled and brave, but it was significant enough to affect combat outcomes consistently. As the war ended and soldiers returned home, the Garand became a symbol of American industrial and military superiority. It represented not just a better rifle, but a better system, an economy capable of mass-producing complex weapons, a training establishment that could teach millions to use them effectively, and a logistics network that could supply ammunition in unprecedented quantities.
Yet the transition was not instantaneous or complete. As late as the 1950s, some armies still issued bolt-action rifles to frontline troops. The lessons of World War II were absorbed slowly, and economic realities often trumped tactical advantages. But the trajectory was clear. The bolt-action rifle that had dominated warfare for 50 years was obsolete, replaced by semi-automatic and automatic weapons that provided the firepower modern combat demanded. The 15 rounds per minute that had seemed adequate in 1918 was pathetically inadequate by 1944. The 40 rounds per minute that the Garand provided became the minimum acceptable standard for infantry rifles going forward. The story of bolt-action rifles versus semi-automatic rifles is ultimately a story of technological evolution driven by the demands of combat. Military conservatism had resisted change, satisfied with weapons that had proven themselves in previous conflicts. But the crucible of World War II forced recognition that firepower had become paramount, that the individual soldier needed to deliver more bullets faster to survive and succeed in modern warfare. The 26 years between Private Dalton working his Springfield Bolt in 1918 and Sergeant Kappa firing his Garand on Omaha Beach in 1944 witnessed a revolution as profound as the introduction of the rifle itself. The manufacturing challenge of producing millions of semi-automatic rifles should not be underestimated. The Garand contained over 50 parts, each machined to precise tolerances. The gas system required drilling a port at exactly the correct position and diameter. The operating rod needed to be machined from high-grade steel, heat-treated to specific hardness. The receiver was a complex forging requiring multiple machining operations. American industry rose to this challenge, with Springfield Armory and Winchester producing thousands of rifles daily at peak production. The precision manufacturing techniques developed for Garand production would later revolutionize post-war consumer goods manufacturing.
Quality control was critical. A bolt-action rifle could tolerate minor manufacturing variations and still function reliably. The soldier could always force the bolt closed if needed. A semi-automatic rifle required all parts to work in harmony, with timing and tolerances critical to reliable operation. American armories developed sophisticated gauging systems and inspection procedures to ensure every rifle met specifications. Rifles that failed inspection were disassembled, faulty parts replaced, and the weapon reassembled and tested again. This attention to quality meant that Garands arriving at the front were reliable and ready for combat.
The training infrastructure required to support semi-automatic rifles was equally substantial. The Army established schools where armorers learned to repair and maintain Garands. Technical manuals were written and distributed, providing detailed instructions for field maintenance and troubleshooting. Spare parts supply chains were established, ensuring that broken firing pins, worn springs, or damaged operating rods could be replaced quickly. This support infrastructure was as important as the rifles themselves, ensuring that weapons remained in service rather than being discarded when minor problems occurred. In the field, soldiers developed intimate relationships with their rifles. Each Garand had its own characteristics, slight variations in how it shot, where it hit, how it felt. Soldiers learned their individual weapons' quirks and preferences. Some rifles preferred to be cleaned after every mission. Others functioned fine with minimal maintenance. Some shot slightly high, others slightly low. Experienced soldiers adjusted their aim based on their specific rifle's behavior. This personalization created a bond between soldier and weapon that transcended mere functionality. The rifle became a trusted companion, a tool that kept them alive.
The sound of the Garand in combat became so distinctive that it could identify American positions instantly. The sharp crack of the .30-06 cartridge was louder than most other rifles, and the rapid semi-automatic fire created a distinctive rhythm. German soldiers learned to recognize the sound and take cover immediately. In night combat, the muzzle flash of the Garand was substantial, making it necessary for soldiers to fire and move quickly to avoid return fire. Tracer rounds, while helpful for aiming, also revealed the shooter's position. Combat was a deadly game of shooting and repositioning, and the Garand's firepower allowed American soldiers to win that game more often than not. Winter warfare presented special challenges. In the frozen forests of the Ardennes during the Battle of the Bulge, temperatures dropped well below zero. Standard gun oil thickened into sludge, preventing the Garand's faction from cycling. Soldiers learned to strip the heavy oil from their rifles and apply only a thin film of lighter lubricant, or even use dry weapons with no lubrication at all. The metal became painfully cold to touch, and soldiers had to be careful not to let bare skin contact the rifle or face instant frostbite. Despite these challenges, the Garand continued to function, its gas operation still cycling reliably, even in extreme cold, as long as proper maintenance procedures were followed. Desert warfare brought different problems. Sand and dust infiltrated everything, grinding away at moving parts and causing premature wear. The Garand's gas system was particularly vulnerable, with the gas port potentially clogging with debris. Soldiers in North Africa and later in the Pacific developed techniques for protecting their rifles, wrapping critical areas in cloth, covering muzzles when not in use, and cleaning obsessively. Units that maintained discipline in weapon care had reliable rifles. Units that became lax faced increasing malfunction rates that could prove fatal in combat.
The jungle environments of the Pacific presented perhaps the harshest conditions for the Garand. Constant humidity caused rust to form overnight on any exposed metal. Soldiers applied heavy coats of oil to prevent corrosion, then had to clean the excess before combat to ensure reliable function. Vegetation fouled actions and muzzles. Rivers and streams meant weapons were frequently submerged. The en-bloc clip system could allow water to enter the action if the rifle was submerged with the magazine loaded. Despite these challenges, Marines and Army soldiers in the Pacific maintained their Garands in fighting condition through constant vigilance and care. Ammunition expenditure in the Pacific was enormous. In jungle combat, where visibility was measured in yards, soldiers fired at sounds, at movement in vegetation, at suspected enemy positions. The Garand's 8-round capacity meant constant reloading. Supply sergeants struggled to keep pace with ammunition consumption that exceeded anything seen in Europe. Some units fired over 200 rounds per man per day during heavy combat, 10 times the expenditure rate of WW1. This consumption was sustainable only because of the massive American logistics system that kept supplies flowing across thousands of miles of ocean. The iconic battles of WW2 showcase the Garand's capabilities. At Guadalcanal, Marines armed with Garands held Henderson Field against repeated Japanese attacks, their rapid fire breaking up banzai charges that would have overwhelmed bolt-action armed defenders. At Iwo Jima, the ability to deliver sustained fire while advancing across open beaches made the difference between success and catastrophic failure. In the hedgerows of Normandy, American soldiers used Garands to suppress German positions while infantry maneuvered to flank them. At Bastogne, surrounded and outnumbered, American forces held partly because their individual riflemen could outshoot German infantry 3-1.
German tactical responses to the Garand evolved throughout the war. Initially, German infantry tried to engage American forces in traditional firefights, quickly discovering this was suicidal. They adapted by emphasizing machine gun positions and prepared defenses where overlapping fields of fire compensated for their riflemen's lower rate of fire. They increased the number of machine guns per squad, attempting to match American firepower through crew-served weapons. They developed assault tactics using submachine guns for close combat, where the Garand's range advantage was negated. None of these adaptations fully compensated for the firepower gap, but they made combat more expensive for American forces. The Italian campaign demonstrated the Garand's effectiveness in mountain warfare. In the steep terrain of the Apennines, where maneuver was restricted and combat often devolved into small unit actions at close range, the ability to deliver rapid fire was crucial. American infantry advancing up slopes under fire used Garands to suppress German positions on ridgelines above them. The volume of fire kept German defenders from aiming effectively, allowing American soldiers to close with enemy positions. In these grinding battles of attrition, superior firepower often determined who held the high ground at day's end. The crossing of the Rhine showcased American firepower at its most devastating. As assault boats crossed the river under fire, riflemen armed with Garands provided covering fire that exceeded what entire companies could have generated in World War I. The suppression allowed engineers to build pontoon bridges under enemy fire, a task that would have been impossible against unsuppressed defenders. Once across, infantry with Garands cleared German positions through fire and movement tactics that relied on continuous suppressive fire. The Rhine crossing, accomplished in days rather than the weeks or months such operations took in World War I, demonstrated how firepower enabled maneuver. Post-war analysis by military historians consistently highlighted the M1 Garand as a decisive advantage for American forces. Studies comparing American and German infantry effectiveness in similar tactical situations showed that American units consistently achieved objectives with fewer casualties when firepower was the primary factor. German advantages in areas like artillery and armor were well documented, but at the rifle squad level, Americans dominated. This superiority was attributed primarily to the Garand, with secondary factors including better training and logistics support. The Germans themselves acknowledged this in post-war interrogations and memoirs. Wehrmacht officers interviewed by Allied intelligence consistently mentioned American infantry firepower as a significant problem. Some claimed that facing Garand-equipped infantry was more difficult than facing Soviet forces, despite the Soviets' numerical superiority, because Soviet infantry mostly carried bolt-action rifles and were easier to suppress. The psychological impact of being consistently outshot eroded German morale and made defensive operations increasingly difficult as the war progressed. The final campaigns in Germany saw the Garand used in urban warfare, a role for which it was not specifically designed, but for which it proved surprisingly effective. In house-to-house fighting, the ability to fire rapidly at close range was critical. Soldiers clearing buildings needed immediate response when encountering enemy troops in rooms and corridors. The Garand's semi-automatic action meant soldiers could fire multiple shots in the time it took a German soldier to work his bolt once.
This split-second advantage saved American lives in the brutal, close-quarters combat of German cities.
The evolution from 15 rounds per minute to 40 represented more than a numerical increase. It represented a fundamental transformation in what an infantryman could accomplish. The WW1 soldier was a shooter, carefully aiming each shot, conserving ammunition, operating as an individual marksman. The WW2 soldier was a fire team member, delivering volume of fire to suppress enemies while teammates maneuvered, operating as part of an integrated unit. The rifle had evolved from a precision instrument to a fire support weapon, and tactics had evolved accordingly. Training reflected this philosophical shift. WW1 marksmanship training emphasized hitting small targets at long range, with soldiers spending weeks perfecting their aim. WW2 training still valued marksmanship, but emphasized rapid fire at combat ranges. Soldiers learned to fire from various positions, to engage multiple targets quickly, to reload while moving. The Mad Minute demonstrations of WW1, where exceptional soldiers fired 30 rounds in 60 seconds with bolt actions, became routine training exercises where average soldiers exceeded that rate with Garands. Excellence had been democratized through technology. The economic impact of semi-automatic rifle adoption extended beyond manufacturing costs. The increased ammunition consumption required expanded production facilities for cartridges, brass, powder, and primers. The United States built enormous ammunition plants that operated around the clock. Lake City Arsenal alone produced over 4.5 billion rounds of small arms ammunition during the war. This industrial mobilization created hundreds of thousands of jobs and represented a massive investment in military capability. The ammunition supply chain, from raw materials through manufacturing to delivery at the front, became a critical component of American military power.
The environmental impact of this ammunition expenditure was substantial. Firing ranges and battlefields were littered with spent brass casings. Each Garand clip ejection added to the debris. After major battles, the ground was carpeted with brass and steel. Cleanup operations collected thousands of tons of spent casings for recycling. The brass was recovered, remelted, and formed into new cartridge cases, creating a recycling loop that helped sustain the enormous ammunition production. This attention to resource recovery reflected American industrial efficiency and the understanding that every brass casing recovered reduced the need for new raw materials. The cultural impact of the M1 Garand extended beyond its military effectiveness. The rifle became an American icon, featured in war bond posters, newsreels, and press photographs. It represented American technological superiority and industrial might. When soldiers posed for photographs, they invariably held their Garands, the rifle becoming a symbol of the American warrior. Post-war, the Garand was celebrated in films and literature, cementing its place in American military mythology. Veterans kept Garands as souvenirs when allowed, treasuring them as tangible connections to their service. The comparison with other nations' rifles highlighted American advantages. The British Lee-Enfield, while having a faster bolt action than most competitors and a 10-round magazine, still could not match the Garand's rate of fire. British soldiers who later trained with Garands through Lend-Lease programs consistently praised the American rifle's firepower. Soviet SVT-40 rifles, produced in modest numbers, suffered from reliability problems and were withdrawn from frontline service by 1944. Japanese Arisaka rifles were well made but bolt action,
leaving Japanese infantry at a severe disadvantage. Only the German STG-44 assault rifle approached or exceeded the Garand's tactical effectiveness, but its late introduction and limited production meant most German soldiers never used one.
The lasting influence of the M1 Garand on post-war rifle design cannot be overstated. Every major military rifle developed after World War II incorporated lessons learned from the Garand. Gas operation became the standard for semi-automatic and automatic rifles. The importance of reliability and ease of maintenance proven by the Garand influenced design priorities. The concept of a general-purpose infantry rifle capable of engaging targets at range while delivering high rates of fire became doctrine. The M14, M16, AK-47, and FN-FAL, and every modern military rifle trace their conceptual lineage to the Garand and the revolution it represented. As World War II ended and soldiers returned home, they carried with them the knowledge that they had fought with the best infantry rifle of the war. The bolt-action rifles of their fathers and uncles, the weapons that had seemed adequate in 1918, were revealed as relics of an earlier age. The transformation from 15 rounds per minute to 40 had changed warfare fundamentally. Infantry could now assault prepared positions with reasonable expectation of success. Defense required more than rifles and trenches. The stalemate of World War I had been broken not just by tanks and aircraft, but by the humble infantry rifle, evolved into a weapon of devastating capability. The soldiers of 1918 and 1944 would have recognized each other as infantrymen, as men who carried rifles and closed with the enemy. But the weapons they carried and the tactics they employed were separated by a gulf as wide as that between musket and rifle. The bolt-action rifle required constant attention, manual operation, and careful ammunition management. The semi-automatic rifle operated with mechanical reliability, requiring only that the soldier aim and pull the trigger. This simplification of the firing process allowed soldiers to focus on tactics, on survival, on winning rather than on operating their weapon.
The legacy of this revolution persists today. Modern infantrymen carry rifles capable of fully automatic fire, but they're trained to use semi-automatic mode for most engagements, conserving ammunition and maintaining accuracy. The lessons of the Garand era, that controlled rapid fire is more effective than spray-and-pray automatic fire, remain relevant. The balance between rate of fire and accuracy, between firepower and ammunition supply, continues to shape infantry tactics and weapon design. The Garand established principles that endure in modern military doctrine. Thank you for watching this deep dive into one of military history's most significant technological transformations. If this story of firepower evolution fascinated you, shocked you, or taught you something new about how individual weapons changed warfare, do us a huge favor. Like this video, share it with someone who loves real military history, and subscribe to this channel, because tomorrow we're uncovering another forgotten revolution where technology met tactics, where soldiers adapted or died, and where the gap between old and new determined who lived and who fell. We research for long hours every day, cross-check every fact, and write every line to make you feel like you are in that trench, gripping that rifle, feeling the difference between working a bolt and pulling a trigger that fires again and again and again. This is not Hollywood. This is history. Raw, real, and relentless. See you in the next video very soon. Take care, and never forget, behind every technological leap, there were men who bled to prove its worth.